So the command pattern in Dart, because Dart is awesome. In this screencast, we look at macro commands, commands composed of other commands. We'll also use this to discuss just how much information a command object should store for undo. The command pattern encapsulates actions into tiny, well-encapsulated objects, like the move forward command, which tells a robot to move direction north. It makes for easy compositing. Macro commands can be used to record user input for later replaying. It can also be used to assemble an action, like opening a template by creating a new document and then inserting a template file into it. This creates a new command, a macro command, create from template. Now, how does this affect our robot from last night? For our robot, we've had nice little discrete commands, but we want to make a nice happy dance command. For that, we want to move forward, move to the right, move to the left, move back to the right, move backwards, and we're done. And the combination of all these commands makes a macro command. Now, implementation of macros is pretty darn easy. We have our individual commands previously. Now we want to combine them into a new command that calls each in turn to make the robot dance happy. So our happy dance command implements command, takes a receiver, the robot. When we construct it, it needs this robot instance to work on, to call actions on. And now we're going to assemble a bunch of other commands to call on the robot. We're going to move it north, then move it east, move it west, and each time we're doing this, we're calling these actions. So this call, our macro command, is being called, and in turn it's calling these individual subcommands. All right, now we need to create a new button, a happy button. It's going to tell our robot to do a happy dance. And then we want to go ahead and press that button. Let's see what that does. There we go. We have our happy dance. Moves direction north, then east, west, back east, then south, and we end up at 1, 0. So that's great. What about undo? So if we go ahead and we're moving back and forth and then down, and we end up here, the easy way to do undo is just to go backwards and reverse order each one of those commands until we get back to the starting point. So let's go ahead and implement that. Create an undo method, copy all those commands, reverse that region, and call undo on each one of those in turn. So the south command was the last one, we'll undo that all the way to the north one. And then down here, we'll do a button undo. We'll run our code. And there we go. We ended up at 1, 0 when we did it, then we did undo. We're undoing an instance of our happy dance command. We do north instead of south, east instead of west, and south instead of north, and we end up at 0, 0. Now, that's not the quickest way to do it. If we want to do a real reverse, we don't want to retrace all of this path that the robot is going on. We just want to go back to the starting point. It should be one step. Let's go back up into our undo, get rid of all of this stuff, except for moving west. We want to just move west, and we want to call that command instead of undoing. So go ahead and call that, and there we go. We're undoing our instance of happy dance, and that moves west, and the end result is 0, 0. Now, that's not necessarily the most robust or long-term solution. So let's go ahead and store the previous state of the robot. And this is something that command objects are going to have to do the more complex the undo, the more complex the state we're representing becomes. So we store the previous X and Y position when we call it. And now we're going to decide, all right, the direction we need to move. If the robot's X position is greater than the previous X position, then we need to go west. Otherwise, we go east. And while the robot X is not equal to the previous X position, We'll just move in that direction. And we'll do the same thing for the Y position. And there we go. We have a more robust solution. At the expense of just a little bit more internal state that we had to remember about the robot when we called it in the first place. And that about does it. As always, find out more at designpatternsindart.com. Thanks.